Welcome back. Today we are doing lesson 1.7, measuring volume by counting cubes. So our objective is going to be able to discuss the benefits of using unit cubes to measure volume and also understand the concepts of volume. That second objective is a continuation from the previous lesson. Let's first get our mind warmed up with a little mental math. We have 3 expressions here. I would like you to try on a slate or a piece of paper, practicing doing things in parentheses first before moving on. So we have 3 times 2 plus 4 times 3. Then we have 42 divided by 6 times 27 divided by 9. And then finally 12 plus 48 divided by 8 minus 7. Take a second, pause your video here, and come back and check your work. All right, so for the first one, you should have found that was 6 plus 12 equals 18. The second one, 7 times 3 equals 21. And the last one, 12 plus 6 minus 7 equals 11. Another term to write into your notebook is a cubic unit. Last time we had rectangular prism. This time it's cubic unit, and that is a unit such as a cubic centimeter or a cubic foot used in measuring volume. Now, today's lesson is another hands-on lesson. You do have these in the back of your math journal. So this is going to be another 2-part lesson with videos. The first one I'm going to be talking about it, and the second video I will show you a demonstration of doing this. So again, in the back of your math journal, you'll find you have, it's in the very back. I'll have to give you that in the instructions of what page that is in your math journal, but then you'll use page 18 to fill out a chart. So you'll see you have rectangular prism A, B, and C. And what you'll do is you'll cut along the dotted lines. So you'll want these little flaps off to the side because what these will create are your actual paper cutouts of rectangular prisms. So you'll have rectangular A, B, and C. In part 2, you'll see that I'm going to use cubes, and we will be estimating how many will fit into it. So you can actually do your estimation prior to part 2 video. So taking a look at page 18, after you have assembled your prisms, these 3, and you can glue on these little flaps or you can tape them together, and you will see in part 2 what those look like. But once you have completed putting those together, I want you to make an estimate on page 18 in your math journal and estimate how many cubes do you think it will take to fill rectangular prism A, B, C. And as you're doing that, I want you to think through these questions here. Could a square pattern block, like we used last time, we found that square pattern block was the best pattern block to use. But do you think we could use the square and a cube to pack a prism without gaps or overlaps? Could both shapes fit in the corner of a prism? And what do you think? Do you think a cube or a square pattern block is better for measuring volume? Why do you think that? Well, today we're actually going to use cubes to measure the volume of rectangular prisms, and that's again what you'll see in part 2. Remember when we packed our prisms with the pattern blocks, the results showed that the square pattern block was best. And when we're using cubes, we're going to measure each cube as a side length of 1 unit, and it's called, again, a unit cube. The volume then of each little cube is 1 cubic unit, and a cubic unit can also be written with units to the 3rd power. Units to the 3rd power. So how many unit cubes do you estimate would fit into each prism? And explain your answer in the text box provided under this presentation. So as we do this, we're going to pack prism A with cubes. And remember, we want to pack them without any gaps, without any overlaps. And then we're going to count the total number of cubes that we used and recorded on journal page 18. And again, when cubes are used to measure, each cube has a side length of 1 unit, and that is a unit cube. So the questions that we're going to be answering are, how many cubes will we need to completely fill prism A? What is the volume of prism A? And finally, why is the number of cubes we use to fill the prism the same as the volume? So these are the 3 questions that we're going to be discussing in part 2 of this video. You'll be able to see me actually do that. So we'll find that rectangular prism A actually has 24, rectangular prism B actually has 20, and rectangular prism C has 18. So we're going to look at solving cube stacking problems. So this picture right here, we see that these problems, you must examine a drawing of the prism partially filled with cubes, and then you have to determine the prism's volume, or the number of cubes that you need to completely fill it. So what do you notice? What do we notice about this picture here? Well, what I'm noticing is that I see that we have cubes going from top to bottom, which would give us the height. I see that it's going from side to side, which would give us a length. And I see it going from front to back, which could give us a width. And I see that height, length, and width is something that we are being provided. So I'm going to count the height, length, and width. So I can see that I've got 1, 2, 3, 4. So my height is 4. And I can go 1, 2, 3, 4, 5, 6. And then we can go 1, 2, 3, 4, and 5 long. So I know that it's going to be 4 rows high, 6 rows wide, and 5 rows deep. I'm going to actually multiply these 3 numbers together, because what this actually comes out to be is our formula for volume. Volume equals length times width times height. So I know that 6 times 4 is 24. So I'm going to write that first. And I'm going to take 24 times 5, which we know, if we solve that, is 120. So when solving this one, we see that it takes 120 cubes to fill this prism, or the volume is 120 cubic units. Okay, so again, the cubes in each rectangular prism below are the same size. Each prism has at least 1 stack of cubes that goes up to the top. You have to find the total number of cubes needed to completely fill each prism. And so the cubes needed to fill this one is 120, giving it the volume of 120 cubic units. Let's do another one together. These are on page 18 in your journal. So I'm looking at this one and I can see the height perfectly. But notice they don't go all the way from side to side, and they don't go all the way from the other side to side. So the length and the width, we don't have one full line. So I'm going to show you here. Height is easy. I'm going to make a little list over here. So the height we can see is 1, 2, 3, 4, 5. That one was simple. Easy to see. And now we need length and we need width. So I'm going to do length in another color here. And I'm going to go from this corner to this corner for length. Well, I can start here because I can see 1, 2, 3, 4, 5. But then I can look, the next one would be 6, 7, 8. We can see that it is 8 long. And then width-wise, I'll do in green. And this time I'm going to go from this corner to this corner. And I can see that we've got 1, 2, 3, 4. It is 4 wide. So we have a 5, 5 high, 8 long, and 4 wide. So we're going to take 5 times 8 times 4. So another way of thinking about this is if we filled up the entire base with cubes, what would we have? So I know length times width would be area. So we're going to take 8 times 4, which is 32. It would take 32 cubes to fill the entire base. So then I'm going to have 5 layers of 32. So we can take 32, because we know that's the area of the base, times 5 layers, and that's going to give us our final answer. And it should be 160. So if we take 32 cubes to lay on the base and 5 layers, we get 160 cubes, giving us a volume of 160 cubic units. Okay, so now turn to journal page 19, and use the strategy you're comfortable with. You can do the length times width times height, or you can do like we did in this one, where you find out what the area of the base is and then creating layers, and go ahead and solve these problems here. So you'll see we have prism 3, prism 4, 5, and then 6 is a try this. So I'd like you to go ahead and try that one. Then come back, pause your video here, and we'll come back and check our answers for 3, 4, 5, and 6. So if you take a look at prism 3 and prism 4, prism 3 was 96 cubes and the volume was 96 cubic units. You could see that you could easily find the length, the width, and the height for this one, getting 96. For prism 4, you see they give you the area of one side, and so you could have come up with that area and figure out how many layers we needed to fill in prism 4. You could have also done the length, the width, and the height, but we come to 80 cubes or 80 cubic units. And prism 5 and 6, we had 210 cubes or 210 cubic units. This one was a little bit more tricky. You could find the height, which was 6. And this one was like one of the examples I gave you where you had to kind of put it together like a puzzle. 1, 2, 3, 4, 5, 6, 7. And then you could have done it 1, 2, 3, 4, 5. So you put those 3 together to come up with 210 cubes to fill that entire prism. And then the try this was 125 cubes, 125 cubic units. Let's look at that one. So it's got some hidden pieces here. So we can write over to the side our height, our length, and our width. Sorry for that writing. It's not perfect. But our height was easy. 1, 2, 3, 4, 5. Our length, we could go 1, 2, 3, 4, 5. And our width, we could go 1, 2, 3. This one's behind it. 4, 5. So we'd have 5 times 5 times 5. And so remember, the area of the base could be a 5 times 5. And then we would take that 25 times 5, because that's how tall it is, to get 125 cubes or 125 cubic units. Again, the cubic units or the unit cubes have a benefit of stacking like the squares, but they give us a solid foundation for stacking them within a prism because they have the same features as a rectangular prism. And the concepts of volume, what we found throughout this was the formula of length times width times height. So after watching this, there are some Khan Academy links like we've done in previous lessons that you can check out and build on today's lesson.